video we're going to be talking about sorting. Now we'll go from basic sorting to actually sorting real life model instances or model objects. Now based on attributes or properties that actually they have in common. Now we're going to be using the sorted keyword and special dunder methods or magic methods as some would say. Now we're going to start by how to sort a simple homogeneous collection. Now we're going to try this in the normal form and also in the reversed form. So enough talking, let's go into it. So first of all, we're going to collect a homogeneous collection of numbers. Now I say homogeneous because the attributes inside the list should actually be related. So I could go ahead and give a random collection of numbers, just any random collection of numbers you can give. And I want to sort this number from the smallest to the largest. Okay, so I want to go 1, 2, 3, 5 and so on. So how am I going to do that? Now I'm going to say create a new keyword, sorted num. We should have given this nums since there are a lot of numbers. So sorted nums is going to be sorted. Now you can see this is a keyword in Python. It's a function and it's going to take the collection here, which is nums. Now we've just assigned this sorted nums to be a new version of this list here. Okay, so we can try to print sorted nums and we'll see what we get. Like you can see we have this wonderfully arranged. Now if you would have done otherwise by putting a string here, this is no longer homogeneous and you would get an error. Okay, so that is why I said sorting involves homogeneous items. Now you could see this works fine for a collection of numbers. Now how well does it do with a collection of strings? Now let's go ahead and create a new let's say fruits. Now it's going to be a collection of fruits, and we're going to say apple, we're going to give a pear, we're going to give a mango, and probably what else? An orange. Okay, an orange, great. So we have a collection of strings, okay, which consists of different fruits. Now I could go ahead to say sorted underscore fruits is equal to sorted. Then we can just give the fruits parameter here, and we could try to print sorted fruits. Okay, so once I run this code, you can see here it changes a little bit. Okay, so we've got apple, pear, mango and so on, but in this case it's kind of like started from an A, which is the apple, it went to an M before an O and then a P, and you can see the basic pattern in the alphabet because it's kind of like picked in such a way that I know some of you have come in contact with some problems, so you have to actually sort names in alphabetical order. If you've not come across this is also very useful to do that. So now if we want to sort these strings in a different format, now that is where the key comes in. Okay, so this sorted function actually takes in 3 parameters. Now it can be the first, the collection, the second is going to be the key, and the third is going to be reverse. That's if you want to do this in reverse mode. Reverse. Okay, so I could go ahead and say the key for this sorting is equal to len. That is the length of these strings. Okay, so let's see what we're gonna get. We want to change, we just do that slight change. Now once I run this, you can see we have pear, which is 4, apple is 1, 2, 3, 4, 5, mango is probably 5, and this is also 5. And I can go jump in here and give a longer one, say pineapple. That should have an E, I guess. So once we sort this, you see that pineapple comes to the last irrespective of the index. Okay, so I can put it at the start, wherever we want to put this. It will still sort this to be at the last once you run the program. Okay, so that is basically it. Now if you want to sort this in reverse mode, you want this to start from the largest or whatever, you can go ahead and specify this by saying reverse is equal to true. Basically when this function is declared, reverse is always false, except you've changed that, and once you change reverse to be true, the reverse of this will be the case. So once I run this, you can see we've got pineapple, orange now in the reverse form, as you can basically see. And that's it for the basic sorting of homogeneous items. Now, what if we had a full model or a real life model that actually handles real life objects, okay, or instances? Now, I've chosen to use the class of students. Now, you can choose whatever you want. You can be employees, but you should still be able to follow up on this tutorial. So I'm going to start by creating a class of students. Student. Hopefully, you got a basic knowledge on object-oriented programming. Now, I'm going to initialize the student, so that init is going to take the self, the first name, the last name, the age, and the total score of the student. That's maybe the total score in a semester or a session, whatever. So we're going to give this self dot first name is equals to first name, self dot last name is equals to last name, then self dot age is equal to age, self dot total score is equal to total score. So during the creation of this student, he might not have a total score, it might be a new student or whatever. So that's why I've specified this to be 0. Now we want to give this user the ability to change the total score of the student. So def, we're gonna change, say set underscore total underscore score. So we're gonna just give a self, and we're gonna stick self and actually a score. Okay, so I'm just gonna give this here. So self dot total score is equal to score, and that will do it for our class. Now let's try to create a class instance and see if we got it wrong anywhere. So I'm gonna create the first student. Actually, we should give spaces. Yes, and someone is complaining. Okay, so we're gonna create the first student. So stud1 is equal to student, and he's gonna have a first name of Jamie Anderson, and he's gonna be 12-year-old, and he has no total score. So let's try to see if our program runs. Fine, our program runs fine. So if we want, we could go ahead and give a total score of whatever we want, which in this case I will totally be doing that. So I'm going to give him a total score of 40 out of 100. Okay, so we're going to create a second student. So stud2 will be a new student. So stud2 will be a student, and we could give any name we want. So John Smith, and he's going to be let's say 19, and his score is, actually we should give it 13. His score should be 50, and I'm just gonna create 5 students. So stud3 is equal to students, just any random name. So Mary, whatever, Judith, whatever you want, 60, and stud4 will equal to new students. These are just instances of this class, and we'll just give whatever we want. Whatever, man, whatever. Mass, Corey, and she's gonna be 13. We'll give her 45, and student 5 is gonna be a new student, and we're gonna give it as any name you want. So I'm actually running out of names. Martins, and Jonathan. Okay, so 14. Let's just give that as a 14 as the age, and then the total score should be 100. Okay, so as you can see, we've created a real life model, and we have some class instances. The aim of this video is actually not to perfect the class, but to show you how this basically works. Okay, so we've gotten a few instances, and we actually want to sort these students based upon the score, the total score that they have in a session. Okay, so we want to sort the students actually by their total score. Now it's not as easy as creating a basic list and saying sorted students. Well, let's try that and see what we get. So we're going to create a basic list and say students is equal to a new list. Okay, and the list is going to contain student 1, student 2, student 3, student 4, and finally student 5. Okay, so as you can see, we can just go ahead and say sorted underscore. I should scroll this down a bit. So sorted underscore student is equal to sorted students. Okay, not sorted, the function itself, so students. So we're trying to sort this one here, and let's go ahead and say print sorted students. Okay, so Control B, and you can see we ran into a basic error. That's because it couldn't sort the instances of our class. Now, how can we implement this to be sortable? Now we're going to use the len function, just as we did in the string. We're going to just assign the len to be the total score, so this class can be, and class attributes can actually be sortable, okay? Or class instances, not attributes. So def underscore underscore len underscore, I'm just gonna give self, and this is just gonna return self dot total score. Okay, so that's simple. We just apply that there, and we can come down in this sorted student, and then we can give key to be equal to len. Okay, so this is how magic method actually work, and they are very useful. If you've not gotten a grasp of them, I'm going to leave a link to my object-oriented programming series so you can check that out. Okay, so this time around, if we try to print sorted student, you would see that that looks horrible. Okay, so it's just giving us the memory locations. So we actually want to see the student's full name and probably the score, and see if it got sorted correctly. So I'm going to define the function here for full name, or just say full name, or let's just give that as an attribute. Okay, so self dot full name is equal to self dot first name plus a space plus self dot last name. So we've got the full name basically set up for us, and now we could go below our code and use that. So what we're going to do is we're going to loop over this, okay, and then we'll print the full name and the total score of the students. So I'm going to say for I in sorted students. Okay, so for I in sorted students, we're just going to print I dot full name plus just anything you want here, then plus I dot total score. So if I run this program, you would see, not Control V please, you would see that we've got, okay, what is the problem? Okay, you can only concatenate strings, not it. Okay, so let's say SGR, because I believe the total score is an integer. So once we run this now, you can see that that is wonderful. We've got Jamie Anderson having 49, Mas Corey 45, 50, 60, then 100. Okay, if you wanted this to be reversed, you can just say reverse equal true, and that basically reverses everything for you. Now in a real life application, you might not want to actually manually add all the students to a list. You might have a basic function that adds students or employees in your case, whatever, that adds them to your database or whatever you really want them to do. And this block of code that's having the list might be for a particular grade of students, because you're not going to be accepting the whole student. Now I've left all this functionality out in this tutorial just to show this basic concept. Now I hope this video was helpful. Now if you want to support this channel or this video, you can do that by leaving a like on this video, subscribing to this channel, and if you have any challenges during the course of this tutorial, you can leave a comment in the comment section below, and I'll do my best to answer those. And I'll be seeing you guys in the next tutorial. Thanks for watching.